The space industry's dirty secret. Most tech is built out of spec, no universal standards, just chaos.
Here's a paradox I love. The more we try to describe everything with one perfect theory, the less of reality we actually capture. Einstein chased a single, elegant foundation for the universe, a unified field theory that would weave gravity electromagnetism into one fabric. He'd already reshaped space and time with general relativity, showing gravity isn't a force pulling on masses, but geometry telling matter how to move. It was clean, deterministic, beautiful. Then quantum mechanics showed up like a dice-rolling gremlin. Down at the smallest scales, particles don't have definite properties until you measure them. They live in probabilities, superpositions, and entanglement. Einstein hated that indeterminism. God does not play dice, right? Here's the critique. By insisting the universe should reduce to one singular basis, one geometric essence, Einstein tried to compress wildly different behaviors into a single mold. That move risks flattening the very complexity that makes the universe work. Think about how we actually do physics now. Instead of one key for every lock, we use a toolkit. For particle physics, I lean on the standard model. Quantum fields gauge symmetry's probabilities baked in. For celestial gravity, I use general relativity, curved spacetime, black holes, gravitational waves. For the expanse, the large-scale universe, I bring in cosmology, expansion, dark matter, dark energy, structure formation. These are modular layers, each with its own rules and range of validity. That's not a failure, it's a feature. Notice the pattern. The smaller and more energetic the scale, the more quantum quirks dominate. The bigger and slower the scale, the more space-time geometry takes the lead. In between there are bridges, semi-classical approximations, effective field theories, and renormalization flows that let ideas talk across scales without forcing them into a single dialect. Einstein's vision wasn't wrong so much as it was early, and maybe too singular. He wanted a final blueprint. Nature seems to prefer modular blueprints that click together where they need to, then mind their own business elsewhere. Consider effective theories. I don't need to simulate every quark to understand why a bridge stands. I use continuum mechanics. I don't need quantum gravity to predict a GPS satellite's orbit. General relativity is plenty. Yet I absolutely need quantum electrodynamics to explain the electron's magnetic moment. Different jobs, different tools. Where do these modules meet? In the extremes. At black holes in the Big Bang, quantum and gravity collide.
Space is not what you think it is. For over a century, our understanding of the cosmos has been built upon a monumental idea, that space and time are fused into a single curving fabric. This concept, born from the mind of Albert Einstein, is called general relativity. It has been a cornerstone of modern physics, explaining gravity as the warping of space-time by massive objects. But what if that foundation, as elegant as it is fundamentally flawed? What if space doesn't curve at all? A bold new framework, the quantum physics theory, invites us to discard the familiar image of a bending, stretching universe and replace it with something far more direct and perhaps more intuitive. This essay will guide you through the core principles of this revolutionary model. We will dismantle the long-held belief in a unified space-time where space is flat, modular, absolute. It proposes that time itself is not a dimension that can be warped, but rather a product of local mechanical processes. The famous equation E equals mc squared, which inextricably links mass and energy, is revisited and challenged, suggesting these two forces operate under separate jurisdictions within the grand cosmic order. Prepare to question what you have been taught about the very nature of reality. The quantum physics theory does not just offer a minor adjustment to our current models, it proposes a complete paradigm shift. It suggests that the universe is not a cosmic trampoline where planets create dents, but a rigid tiled floor where vibrations and fields dictate the motion of everything we see. We will walk through this new architecture piece by piece, using simple analogies to grasp concepts that challenge the giants of scientific history. At the very heart of the quantum physics theory lies a radical reinterpretation, the flat, modular architecture. Forget the idea of space as a flexible, rubber-like sheet that can be warped and distorted by mass. Instead, imagine the universe as an immense, perfectly flat and rigid stage. This stage is not a seamless void. It is constructed from countless discrete units of place, much like a digital image is made of pixels or a floor is made of tiles. Each of these fundamental units represents a single, indivisible location in the cosmos. This gridded structure is the absolute and unchanging backdrop against which all physical events unfold. In this model, the stage itself never curves. It remains steadfastly flat, providing a stable and predictable coordinate system across the entirety of existence. So if space doesn't bend, what role do massive objects like planets and stars play? These objects act as anchors within the grid. Planets, stars. A star, for instance, doesn't create a gravitational well by curving space around it. Instead, its immense mass and density lock down a large number of the surrounding grid tiles, holding them firmly in place. This anchoring effect is crucial as it establishes stable regions where matter can coalesce. Solar systems, galaxies. This concept of a flat anchored grid stands in stark contrast to Einstein's vision of a dynamic space-time. In relativity, the geometry of space is the explanation for gravity, but in the quantum model, the geometry is fixed. The action happens not through the bending of the stage, but through interactions that occur on the stage. Motion force. What we perceive as gravity are consequences of how objects interact with the grid and the fields that permeate it, which we will explore next. The universe's floor plan is simple and absolute, providing a solid foundation without resorting to a flexible reality. Think of it like building with Legos. The base plate is the flat, modular grid of space, rigid and unbending. Blocks representing mass lock onto it. If space is a flat-tiled floor, what fills the gaps between the tiles? What governs how things move across them? The quantum physics theory introduces a new and crucial component, the expanse. The expanse is a universal, non-material field that permeates the entire grid of space. It is not a substance like the historical concept of ether, no density, no mass, no inherent energy. You can think of it as the operating system for the universe's hardware. It is a neutral, massless medium that manages the rules of motion and acceleration, particularly far from a massive anchor, a star, a planet. The most fascinating property of the expanse is its effect on mass and time. Within a localized frame of the expanse, away from anchors, the properties of matter change dramatically. In these deep space regions, objects effectively become massless. Inertia, or resistance to changes in motion, is governed not by intrinsic mass, but by interaction with the expanse itself. Accelerating a spacecraft in interstellar space might require a completely different approach than lifting it off Earth, as mass behaves differently out there. In the quantum model, mass is a localized phenomenon, most pronounced near the large anchors that hold the grid steady, fading as objects move deeper into the expanse. One of the most sacred tenets of modern physics is the constancy of the speed of light. Einstein's special relativity is built on the premise that the speed of light in a vacuum, denoted as c, is the same for all observers, regardless of their motion, the ultimate cosmic speed limit, universal, absolute. The quantum physics theory throws a wrench into this foundational idea by proposing that the speed of light is not universal at all. Instead, it is a localized phenomenon. The maximum speed light can travel depends on the local conditions of the expanse and proximity to a massive anchor. Near a massive star, where the grid is firmly anchored, the speed of light has a specific measurable value, the one familiar near Earth. Far from anchors, the properties of the expanse may differ, and thus the local speed of light could be faster or slower, depending on the field's state. If the speed of light can vary, methods for measuring vast distances, which rely on c as constant, may need reevaluation. Light from a distant galaxy may have crossed regions with different speed limits, altering our age and distance calculations. It also weakens the tight weave between space and time. If c isn't constant, time dilation spaces breaks down. Like sound speeds vary with medium and conditions, quanta suggests light speed is a property of its environment, not an immutable cosmic law. Section 5. The clock on the wall. Time is a local measurement, not a universal fabric. Relativity gave us space-time, where time is a fourth dimension woven with space. Quanta rejects that. Time is not a dimension. Time is a measurement of local, cyclical, mechanical processes. A clock just counts cycles, rotation of a planet, swing of a pendulum, vibration of a quartz crystal, decay of an atomic particle. These are physical events in flat, absolute space. When a satellite clock appears to run differently than one on Earth, we're not seeing time warp. We're seeing a physical effect on the clock from motion from a different gravitational environment. This resolves the twin paradox in quanta. Its mechanics. The traveling twin's body and clock faced extreme acceleration and different field conditions in the expanse. Their biological and mechanical rates altered. Their body's clock ran slower. Time itself was unaffected. Time isn't a dimension to travel through. It's what a clock reads. Compare two watches. One jostle. If it runs off, we don't say time warped. The mechanism was disturbed. Quanta applies that logic to the universe. Section 6, a separation of powers, mass, energy, and the partition of physical laws. Perhaps the most famous equation is E equals mc squared, mass energy equivalence, underpinning nuclear power and how stars shine. The quantum physics theory challenges this unification. It proposes a separation of powers, distinct realms with distinct laws. Mass and energy are not interchangeable. They are different phenomena governed by different rules. Realm 1, particle physics, quarks, electrons, governing subatomic interactions that bind matter. Realm 2, gravitation and mechanics, planets, stars, galaxies, governed by the flat, modular architecture and anchoring. Realm 3, the expanse, with phenomena such as zero-point energy, dictating rules of motion and inertia through the void. By separating domains, the model avoids the intractable unification problem of GR with quantum mechanics. Like government branches, each realm has its role. Forcing them into one creates contradictions. In quanta, each rules its jurisdiction. If space is flat and does not curve, then how does quanta explain gravity? Apples falling, the moon's orbit, gravitational lensing? The answer, vibrations. Tiny ripples travel in the flat grid of space generated by massive anchors. Imagine a taut flat web. A heavy weight fixes a point, pluck a strand, the wave moves outward, not a deep curve, but a dynamic disturbance. Massive objects constantly generate subtle shivers in the grid. When waves meet another object, they nudge it. The pull we call gravity. The same model explains gravitational lensing. Einstein, light follows curved space-time. quanta. Light travels straight across a flat grid but meets a vibrational field near anchors. Ripples act like currents, gently deflecting the beam. Result, light appears bent. Mechanism, flat space with localized disturbances. Enter the graviton, a massless particle whose job is to propagate and reset vibrations at the local light speed. Gravitons are messengers of the gravitational field, keeping the expanse coherent and communicating an anchor's influence, continuous gravity without bending the stage itself. Let's place the two models side by side to appreciate the chasm between them. General relativity, a dynamic four-dimensional space-time. Mass tells space-time how to curve. Curvature tells mass how to move. Space is flexible. Time is relative. C is unwavering. Gravity is geometry, like a marble in a bowl. Quanta, a static three-dimensional space. Flat, absolute, modular time is a measurement of local events. The speed of light is a local variable dependent on the expanse. Gravity is a true force mediated by vibrations propagating across the flat grid generated by massive anchors. A planet orbits the sun not due to curvature but due to constant nudges from outgoing gravitational waves. Relativity, clocks slow because time itself warps. Quanta, clocks slow because gravitational vibrations physically interfere with mechanisms. The effect is real and measurable. The interpretation is different. Warped reality versus a force acting on a device. Why propose such a drastic change? Proponents argue quanta is more intuitive, less paradoxical. By making space modular and separating physical laws into domains, quanta sidesteps conflicts between the smooth world of relativity and the discrete world of quantum mechanics. A scientific theory is only as good as its testable predictions. The quantum physics theory is no exception. Most direct test, variations in the speed of light. If c is local, measure c in different gravitational environments at multiple solar system locations. Another key prediction, lensing character. Relativity predicts smooth, continuous deflection. Quanta predicts a vibrational signature, subtle scintillation or jitter. Make ultra-high resolution observations of lensed galaxies and quasars to seek that signature. If time dilation is mechanical, different clock types respond differently. Atomic versus nuclear. Desynchronization beyond relativity's predictions favors the mechanical view. Probe inertia across orbits and trajectories. Look for resistance to acceleration, changing with distance from the sun or Earth, independent of gravitational pull. Finding this would be monumental. These are hard but possible experiments. The quantum physics theory does not just adjust our view, it asks us to draw an entirely new map. A cosmos built on a flat-tiled foundation where the expanse governs motion. Constants like light speed become local. Time sheds its dimensional status and becomes measurement. Mass and energy are governed by separate laws. Gravity is not a bend, but a shiver propagating across a flat stage. If inertia can be manipulated via the expanse, new propulsion becomes thinkable. Space travel could be transformed. If particle physics is truly separate from gravity, the search for a single theory may give way to clearer modular answers. A flat, absolute stage may resolve paradoxes and clarify the subatomic world. This is an introduction, a powerful what if, not an absolute truth. Science is never settled. It is a call to thinkers, experimenters, explorers to look again, design new tests, and embrace that the universe may be simpler and stranger than imagined. So when you look up, wonder, then test, measure, and observe. The next revolution may be one unexpected measurement away. In physics and biology, the body is affected by gravity. Drop a ball from up high, it falls to the ground. All bodies are ground, the planet's surface. When we grow from a baby, we experience gravity as a play line. Little older, we experience the theory of the gravity force. Finally, when grows somewhat old, we start experiencing change. Our energies slow down, our bodies get heavier. Finally, we start experiencing difficulties. Our body, among main things, get heavier because we have grown our height. Again, our bodies slow down more so than before, and we experience excessive slower physically and gain more weight that gravity stresses on our bodies and our health. We are only human. We have a biological clock-like system about the length of time we exist. Elon Musk, if we can find out what causes this ending cycle on human anatomy, we might be able to change that future 3056.